In the previous class, we have seen introduction to frequency response analysis. Now let us see how to draw the Bode plot. Bode plot. We have seen various types of frequency responses. One of them is Bode plot. Bode plot, we can draw the approximate frequency response without conducting any experiment. Just if we know the transfer function of any system, we can find the frequency response. We know that how it is difficult to find the frequency response experimentally. So that can be easily obtained if you know the mathematical model in terms of transfer function. The Bode plot means it has two parts. One is called magnitude plot, and another one is phase plot. We know that for a system G of S, if you give sinusoidal input with variable frequency, the output also a sinusoidal frequency of variable frequency. For every frequency, what is the ratio between input and output magnitude is called magnitude plot. For varying the frequency from 0 to infinity, and we are finding the output magnitude by input magnitude. If you find the ratio of output magnitude by input magnitude, and if you plot in decibel scale, x-axis is in logarithmic scale and the y-axis in decibel scale, then it is called magnitude plot. Phase plot is for different frequencies, for varying the frequencies, what is the phase shift in the output for every frequency? You will find, if you plot that, then it is called phase plot. Phase plot, that is in degrees. So there are two plots. One is magnitude plot, another one is phase plot. For as frequency varies from 0 to infinity, but constant input magnitude. If you assume it as a unity, then if we have to plot the magnitude plot is modulus of G of j omega. Is nothing but magnitude plot. Modulus of G of j omega, as omega varies from 0 to infinity, is called magnitude plot. Phase plot is nothing but angle of G of j omega, as omega varies from 0 to infinity. It's called phase plot. That we are going to do for various transfer functions. Suppose I'm having a transfer function G of S equal to K upon tau S plus 1 multiplied by tau 1 S plus 1, and suppose this is the transfer function. For that, we have to draw the frequency response. Means the first step is we have to find the frequency transfer function. We have to replace S by j omega. If you replace S by j omega, what you will get? J omega tau 3 plus 1 upon j omega tau 1 plus 1. J omega tau 2 plus 1. This we will get. Replace S by j omega. You will get frequency transfer function. For that, what is magnitude? Modulus of G of j omega, we have to plot as omega varies from 0 to infinity, means modulus of K is K. The modulus of this value is square root of imaginary part square plus real part square divided by square root of imaginary part square plus 1 square root of imaginary part square plus 1. So we got the magnitude. Here we have to vary omega from 0 to infinity, vary omega from 0 to infinity and find this value and plot, that is called a magnitude plot. Phase plot is angle of g of j omega. Angle of g of j omega equal to, this is in one more point we have to consider, this is in linear scale. We are in need of logarithmic scale, decibel scale. So to convert this into decibel scale, 20 log k square root of omega square t cube square plus 1 divided by square root of omega square t1 square plus 1 square root of omega square t2 square plus 1. So log means multiplication become addition. Multiplication becomes addition. That's why it can be written as 20 log k plus 20 log square root of omega square t cube square plus 1 minus, it is in denominator. That's why minus square root of log 20 log square root of omega square t1 square plus 1 minus 20 log square root of omega square t2 square plus 1. So these are all. What is the advantage of writing like this? It is in decibel. Now it is in decibel. Earlier it is in linear scale. Now it is in decibel, dB. dB, decibel. The advantage is we can add for each factor. So if you know the plot for log k and 20 log omega square root of omega square t3 square plus 1, if you know the plot for these two, graphically we can add. Graphically we can add. In the same way, if you know the plots for each factor, we can add them graphically all together so that we will get the Bode plot. That is the advantage. How to add all these plots, that we will see later. So that is the method to find the magnitude Bode plot. It is very simple. If you know the transfer function, we have to deassemble like this. Then we have to find the plot quickly. Quickly we can draw. If you know the transfer function, quick rough plot or approximate plot, we can quickly draw. The approximate plot is called Bode plot. Similarly, we can find the angle also. What is the angle of g of j omega in the present case? K, what is that? G of j omega equal to k, what is that? Omega, j omega t3 plus 1 upon j omega t1 plus 1 multiplied by j omega t2 plus 1. This is the given sinusoidal transfer function. What is the angle of k? Angle of k is imaginary part is 0. Angle means tan inverse of imaginary part by real part. Tan inverse of imaginary part is 0. Therefore, angle of k is always 0. Therefore, angle of g of j omega equal to, for k, angle 0. For this, plus tan inverse of omega t3 divided by 1. No need to write that one. Omega t3 minus, because it is in denominator, tan inverse of omega t1 minus divided by 1 real part. No need to put. So tan inverse of omega t2 divided by 1. This is the angle plot. So we have to vary the omega from 0 to infinity. We have to get different values. We can plot without doing any experiment. We can find the phase plot as well as magnitude plot. That is called Bode plot. So what we have seen here is we can find the plot for each factor separately, and then we can add all together to get the complete plot. So what is the plot for each factor that we have to see? What is the plot for each factor that we have to see? So if we do the partial fraction, any transfer function, you will get k separately. You will get any pole at origin means, that will be there. For that, we can see the plot. Then any derivative factor in the origin, multiple, any s in the numerator. For that also we can plot. Then any first order factor in the denominator, j omega t plus 1, first order factor in the denominator. Similarly, first order factor in the numerator. For that, what is the plot? Apart from that, it may be a multiple repeated poles, n and p, q, p repeated poles and q repeated zeros, like that. For that, we have to see. Then it may be a quadratic, that is s square plus 2 zeta omega n s plus 1. If you write this in time constant form, it will be tau square s square plus 2 zeta tau s plus omega n square. If you write this in time constant form, it will be like this: tau square s square plus 2 zeta tau s plus 1. This is in natural frequency form. This is in time constant form. Always we use time constant form. Why? Because the gain k is correct only in time constant form. That's why always we have to take k. Whenever you want to take k, means the transfer function must be in time constant form, then only the k is correct. So we used to use time constant form for all plots. Other advantages are there for Bode plot that we will see later. Time constant form. So if you write the second order transfer function in the time constant form, it may be this tau square s square plus 2 zeta tau s plus 1. It may be in the denominator or numerator. These are the fundamental factors you may obtain for a given transfer function. If you know plot for all these fundamental factors, you can draw the Bode plot. So let us see one by one how to draw the Bode plot for each factor. So first is, let us take k. Suppose g of s is equal to k, that's all. For that, what is the Bode plot? Magnitude plot is 20 log modulus of g of j omega. That is equal to, because g of j omega equal to what? G of j omega equal to k. Therefore, 20 log modulus of g of j omega equal to 20 log k. That's all. If you vary omega, k won't change. It is independent of omega. That's why for different values of k, what you will get, you have to check. If k is greater than 1, suppose k equal to 1, what you will get? 20 log 1 equal to 0 dB. If k equal to 1. If k equal to 1. If k is greater than 1, k is greater than 1, what you will get? Suppose k equal to 10. 20 log 10 equal to what? K equal to 10. 20 log 10 equal to 20 dB. You are getting, if it is k is greater than 1, if k is greater than 1, say k equal to 10, you will get a positive constant. Suppose k is less than 1, k equal to 0.1. K equal to 0.1. What you will get? 20 log 0.1. That is equal to 20 log 0.1 to the 10 to the power minus 1. 10 to the power minus 1 is nothing but 0.1. 10 to the power minus 1 is 0.1. 1 by 10. 10 to the power minus 1 equal to 1 by 10. That is 0.1. So if you write like that, what you will get? A minus 20 log 10. That is equal to minus 20 dB. If k is 0.1, you will get minus 20 dB. K is greater than 1, let's say 10, you will get 20 dB. If k equal to 1, you will get 0 dB. What is the plot? Magnitude plot. The magnitude plot is log f. In a logarithmic scale, how you will put 0.1, 1, 10, 100, like that you will write. Am I correct or not? Each division is one decade. One decade. That is called one decade. 10 times a fold of 10. If you multiply 0.1 by 10, you will get 1. If you multiply 1 by 10, you will get 10, like that. So fold of 10. What is the previous, before that, what will be there? 0.01. Before that, 0.001. It never reached 0 because log 0 is undefined. Log 0 is undefined. That's why there is no x-axis value 0. So 0.01, 0.001, like that it will go. So here, usually we start with 0.1. In a special cases, we'll start with 0.01 or 0.001, like that. Usually we start with 0.1, 0.1, 1, 10, 100, like that. Here, what is the value? Y-axis in dB, x-axis in log f. Log f we marked in semilog sheet. In semilog sheet, you have to buy semilog sheet. Here, you will get 0. You will get 0. You will get 0 dB. 0 dB. That is k equal to 1. K equal to 10. K equal to 10. What you will get? Plus 20 dB. Plus 20 dB. If k equal to 0.1, you will get minus 20 dB. Minus 20 dB. When k equal to 0.1, you will get minus 20 dB. A horizontal line you will get. A horizontal line you will get. So this is the plot for k. What is the angle? Phase plot. What is the angle? Phase plot. What is the phase plot? Log f 0.1, 1, 10, 100, like that you will get. 1 hertz, 10 hertz, 100 hertz, 0.1 hertz, like that. Phase plot is for, it is only real part, no imaginary part. That's why always angle is 0. So the phase plot is 0 degree. 0 degree. Phase plot is like that. This is phase plot. Phase plot. This is magnitude plot. Magnitude plot. This is for k equal to 10, k equal to 1, k equal to 0.1. This is the magnitude plot for k equal to 10, k equal to 1, k equal to 0.1. And phase plot, whether it is k equal to 10 or 1 or 0.1, phase plot is same. For all values of k, the phase plot is 0 only, 0 degree only. Here, how we will mark frequency will be marked as 1, 10, 100, log f. Or you can write 1 can be written as 10 power 0, 10 power 1. Sorry, 1 can be written as 10 power 0. 10 can be written as 10 power 1. 100 can be written as 10 power 2. And 0.1 can be written as 10 power minus 1. Like that also you can write. Already we have seen that what are the factors in a transfer function. K already we have seen. And S in the denominator. S in the denominator. For that, what is the Bode plot? For each factor we'll see separately, then finally we'll add all together. So for that, 1 by s, g of s equal to 1 by s. For that, the sinusoidal transfer function g of j omega equal to 1 by j omega. Or it can also be written as minus j by omega. Multiply the numerator and denominator by j, you will get minus j by omega. What is modulus of g of j omega? Equal to 1 by omega. That's all. Modulus of g of j omega, how you will find the square root of real part square, 0 square plus imaginary part square, 1 by omega square, that is equal to 1 by omega. So we got, what is the angle? Angle equal to tan inverse of imaginary part. What is imaginary part? 1 by omega, that is imaginary part. What is denominator? Real part? Real part is 0. Therefore, that is infinity. Therefore, angle of g of j omega is, angle of g of j omega is always minus 90 degree. This is minus infinity. Minus infinity, that's why always minus 90. Minus 90. So angle always minus 90. But this will vary. Magnitude plot will vary. So how to plot that? Let us plot a rough plot for 20 log decibel scale. 20 log 1 by omega. G of modulus of 20 log 20 log modulus of g of j omega equal to 20 log 1 by omega. 20 log 1 by omega, when omega equal to 1, you will get 0. When omega equal to 1, 20 log 1 by omega equal to 0. Because 20 log 1 equal to 0. Omega equal to 10, what you will get? 20 log 1 by 10. That is 20 log 0.1. That is 10 power minus 1. That is equal to minus 20 dB. Minus 20 dB. Am I correct or no? When omega equal to 10, 20 log 1 by 10. That is equal to 10 power minus 1. That minus 1 will come here. That minus 1 will come here. Any power will come as product in logarithmic scale. Therefore, minus 20 dB. You will get log 10 equal to 1. Log to the base 10 we are using. So minus 20 dB. When omega equal to 0.1, what you will get? 20 log 1 by 0.1, that is equal to 20 log 10. 1 by 0.1 equal to 10, that is equal to 20 dB. When omega equal to 0.1, it is 20 dB. When omega equal to 1, it is 0 dB. When omega equal to 10, minus 20 dB. So what is the plot? The plot is like this. The plot is like this. This is log omega. How we will mark 0.1, 1, omega equal to 0.1, 1, 10, 100, like that we will mark. So when omega equal to 1, what's its value? 0 dB. This is 0 dB. When omega equal to 1, you notice here, when omega equal to 1, 0 dB. That's why 0 dB. When omega equal to 10, minus 20 dB. Minus 20 dB. Here. So when omega equal to 10, minus 20 dB. When omega equal to 0.1, it is 20 dB. 20 dB. 20 dB. When this is omega equal to 0.1, this point is omega equal to 10. This point is omega equal to 1. So what you are getting? The plot is like this. The plot is like this. What is the difference between 0.1 and 1? 0.1 and 1. 20 dB. 20 dB. Difference between the magnitude change in 0.1 to 1 is 20 dB. Again, 1 to 20, what is the change? 0 to minus 20. Again, 20 dB decreases. It decreases at the rate of 20 dB. 20 dB per decade. This width is called 1 decade. So it decreases at the rate of 20 dB minus 20 dB per decade. Like that we can write minus 20 dB per decade. Like that it decreases. So therefore, if we S in the denominator, a slant line at it decreases at the rate of minus 20 dB per decade. That's all. We have to draw a horizontal, inclined line with a slope of minus 20 dB per decade. 1 decade means 0.1 to 1 is 1 decade. 1 to 10 is 1 decade because it is tenfold. If you multiply by 10, you will get the next. Multiply 0.1 by 10, you will get 1. If you multiply 1 by 10, you will get 10. If you multiply 10 by 10, you will get 100. Therefore, 1 decade. The slope is for 1 by S is, it decreases at the rate of minus 20 dB per decade. That's all. So what is the phase plot? Already we have seen that phase plot is because of real part is 0. Therefore, infinity we got always minus 90. Therefore, the phase plot is looking like this. If you draw the phase plot for this, this is the phase plot. Log F 1 10.1 omega equal to. This is omega equal to or log omega, or simply you can write logarithmic scale log omega you can write. Here it is always minus 9. Always minus 9. This is the phase plot. Phase plot of 1 by S. This is magnitude plot of 1 by S. That's all. Suppose this is the, you see that this is omega equal to 1. Here omega equal to 0.1. Omega equal to 10. Omega equal to 100. So the magnitude, if you see, when omega equal to 1, 0. When omega equal to 10, you will get a minus 20. Minus 20. When omega equal to 0.1, plus 20. This is, the slope is minus 20 dB per decade. The phase plot, always minus 90 degree. Always minus 90 degree. Always minus 90 degree. Because real part is 0. Suppose I am having, instead of S, I am having G of S equal to 1 by S square. What you will get? G of J omega equal to what? G of J omega equal to 1 by J omega square. J omega square. What you will get? Modulus of G of J omega equal to modulus of G of J omega equal to 1 by omega square. Angle of G of J omega equal to what? Angle of G of J omega equal to 2 J omegas. For 1 J omega 90. For 2 J omegas 180 degree. So it can be written as 1 by J omega, 1 by J omega. For this for minus 90 degree, for this another minus 90 degree, therefore 180 degree. Or we can write 2 times tan inverse of imaginary part is omega, real part is 0. Therefore, minus, why minus in the denominator? So minus 2 times 90 degree, that is equal to minus 180 degree. The phase plot is always minus 180. If it is instead of, what is magnitude plot? 1 by omega square means 20 log 20 log modulus of g of j omega equal to 20 log 1 by omega whole square. That is equal to 40 log 1 by omega. 40 log 1 by omega. That can also be written as minus 40 log omega. Omega can be written as omega to the power minus 1. So if you bring that minus 1 as a multiplication factor, you will get minus 40 log. So when omega equal to omega equal to 1, what you will get? 0 dB. 0 dB. When omega equal to 10, when omega equal to 10, omega equal to 10, what you will get? Minus 40 dB. When omega equal to 0.1, plus 40 dB. Plus 40 dB. Because omega 0.1 equal to minus 1. So minus of minus plus, therefore 40 dB. So here, if it is 1 by s square means, what is the plot? 1 by s square means, here instead of 20, 40, here instead of minus 20, minus 40. That's all. The slope is minus 40 dB per decade. If it is 1 by s square. S cube means 3 times minus 60, 0, minus 60. Sorry, 60, 0, minus 60. Slope will be like that. So n means what? What is the, if it is instead of 2, n is there. So what you will get is 20 log modulus of g of j omega, when that is equal to 20 log n multiplied by, because g of j omega equal to 1 by j omega to the power n. So n times 20 log 1 by omega you will get. So we have to multiply. If you know 1 by omega, we can find any number. So just we have to multiply by that power. Just to multiply here, in this case, the power is 2. Therefore, 20 becomes 40. If power is 3, it becomes 60. Plus 60 minus 60. But anyhow, for omega equal to 1, always 0. Omega equal to 1, always 0. This is the plot for 1 by s. This is to know about plot. Already I told you that the distance between, this is 1, omega equal to 1. Omega equal to 1. This is omega equal to 0.1. This is omega equal to 10. Here omega equal to 100. Omega equal to 0.1. Omega equal to 1. Omega equal to 10. Omega equal to 100. What is the distance between these two? The distance between 0.1 and 1 is 1 decade. Already we have seen. 1 decade. Omega equal to 1 and omega equal to 10, the distance is called 1 decade. 1 decade. Therefore, the slope is mentioned as 20 dB. The slope here is minus 20 dB, minus 20 dB per decade. That's why in 1 decade, the magnitude decreases by 20 dB. That's why the slope is called minus 20 dB per decade. Here in 1 decade, here the value is 1. Here the value is minus 20. You notice that here the value is minus 20, here 0. But the distance between these 2 points is 1 decade. Therefore, the slope is minus 20 dB per decade. Decade means 10. So, yeah, multiplication factor of 10. That's why it is called 1 decade. Another scale is there, that is called the octal. Octal. 20 dB per decade and minus 6 dB per octal. Both are same. 6 dB per octal means the frequency will be doubled. Frequency will be doubled. Here it is 0.1. Here 0.2 doubled. 0.3. This is 1. This is 0.9. Here frequency is doubled. 0.4 means here frequency is doubled. So when the frequency is doubled during this period, the frequency is doubled. What is the decrease in amplitude? Minus 6 dB. Therefore, 20 dB per decade as well as 6 dB per octal, both are same. Sometimes they may mention minus 6 dB per octal. So you should understand that both are same. Both are same. There are two scales. One is octal scale and decibel scale. 1 decade means multiplication of 10 frequency. Octal means doubled, twice, doubled. So octal scale means minus 6 dB per decade. Integral factors, that already we have seen. 1 by s power n means 1 by s power n means in decibel scale 20 log modulus of g of j omega equal to 1 by modulus of s power 20 log modulus of 1 by s power n. So that is equal to n times. So this can be written as 1 by s whole power n. Therefore, n times 20 log 1 by j omega to the power n. So j omega modulus of j omega to the power n that is equal to 20 log modulus of 1 by j omega to the power n. So n 20 log 1 by j omega, modulus of j omega is 1 by omega. You will get minus n 20 log omega. Therefore, you will get when omega equal to 1, 0 dB. When omega equal to 0.1, you will get plus 20. Because of 0.1, you will get another fractional number means negative. You will get another negative. Therefore, plus n 20 dB. If it is 10 means, if it is omega equal to 10 means you will get minus n 20 dB. If n equal to 2, what you will get? 40, 0, minus 40. N equal to 3 means 60, 0, minus 60 you will get. Bode plot at a derivative factor, 0 at the origin. That is g of s equal to s. For that, what is the Bode plot? G of j omega equal to j omega. Or it can be written as modulus of j omega equal to omega and angle equal to what? Imaginary part is omega. Real part angle equal to tan inverse of imaginary part is omega, real part is 0. Therefore, infinity. Tan inverse of omega infinity equal to tan inverse of infinity equal to 90 degree. You will get 90 degree. So angle of g of j omega always 90 degree. G of j omega equal to always 90 degree. Always 90 degree. So what will happen if omega equal to 0.1? When omega equal to 0.1, if we substitute that 20 log 0.1 equal to omega equal to 0.1 means you will get 20 log 0.1 equal to 10 power minus 1 minus 20 dB. When omega equal to 1, 20 log 1 equal to 0 dB. When omega equal to 10, what you will get? 20 log 10 equal to 20 dB. So as omega increases, it increases. Therefore, the plot is when omega equal to 0.1, minus 20 dB. When omega equal to 1, 0 dB. When omega equal to 10, omega equal to 10, 20 dB. So it increases. Therefore, the slope is 20 dB per decade plus positive. 20 dB per decade, positive slope. It increases per decade. What is the slope, what is the phase plot? Phase plot already we have seen always 90 degree. Therefore, phase plot is 90 degree always for 0.1, 1, 10, 100 for all. You got 90 degree always. Multiple factors. G of j omega equal to s power n. S power n. In that case, what you will get? Modulus of g of j omega equal to modulus of j omega to the power n, you will get. That is equal to, therefore, 20 log modulus of g of j omega equal to 20 log in dB scale, modulus of j of j omega, that is omega we can put to the power n, that is equal to n 20 log omega. When omega equal to 1, you will get 0. When omega equal to 0.1, you will get minus n20. When omega equal to 10, you will get n20. So we have to multiply by n. Slope is positive. If s in the numerator, slope is positive. S in the denominator, slope is negative. That's all. That is the only difference. But what is the phase plot? Phase plot is j omega. Suppose n equal to 2 means j omega multiplied by j omega. For this 190 degree, for this another 90 degree, therefore 180 degree. For n equal to 2, you will get 180 degree. N equal to 3, 270 degree, like that. What is the difference here? Plus 180 degree. 1 by s means minus 90 degree. S in the numerator means g of j omega equal to j omega means plus 90 degree. G of j omega equal to 1 by j omega means minus 90 degree. That is the difference. In the phase plot, that is the difference.